Hi, everyone. My name is Tiffany Brown, and I am the founder and CEO of Gillis Education. I am so excited to be joined today by Rebecca Brown, one of our tutors and consultants, and she's going to give us a mini math workshop on key geometry principles. This workshop is perfect for middle schoolers, like seventh and eighth graders who have been introduced to geometry and algebra principles, as well as high schoolers, I would say ninth, 10th graders, even 11th graders who need a bit of a refresher on some key geometry principles. And so we encourage you, if you are watching live, to drop questions in the chat. If you are watching this after our live showing, you can always email us to receive the handout that Miss Rebecca is going to be using during the workshop. And if you're a client of ours or a subscriber to our members only section of our website, you'll have access to this workshop, whenever you need it on demand. So I will pass it over to Miss Rebecca shortly. I do want to note that Miss Rebecca has tons of experience teaching math, developing math curricula, and she has tutored for years. And so she is just a gem when it comes to breaking down complex math problems and making them easy for our students and making them just a little bit easier to understand. And again, this math workshop is all about key geometry principles. And so middle schoolers and high schoolers, it's great for you. Also, if you're studying or preparing for a standardized test like the SAT or ACT, even the ASVAB, the military test. These are all really good problems to help you prepare for those sorts of standardized test situations. But I will pass it over to Miss Rebecca. She will be going through again a worksheet that she developed. And if you want access to that worksheet, please just send us an email. And if you're a current client, it will be made available on our members only section of the website. So, Miss Rebecca, take it away.
Hi, I'm Miss Rebecca. I was very excited for this to be our first workshop like this because geometry is something that we actually do use all the time. If you have a project at home or at work, there's a lot of times something you need to know the area or the volume or the surface area or the circumference of something to be able to know how much material to buy or how much time to spend. So I have 4 problems that we're going to go through today that are all about household projects that you might have to do someday. And there are also definitely questions that could be on a standardized test in the future. The hardest part about these usually is figuring out, first of all, what shape you have. That's a big key because what shape you have determines what formula you're going to use. Once you know the formula, all you do is plug the numbers into the formula and you have your answer. So that's the part that students usually struggle with. It's not the math part. Usually by geometry, you know how to solve for X. That's not too bad. But sometimes just translating this problem into a picture or into a formula is the hard part. So let's take a look at some problems here. Let me share my screen. So you can see this worksheet that I made. So first of all, we have Amanda. And she is going to be mulching a circular garden that goes around the base of a fountain. And let me actually see if I can make this bigger here. That's a little better. So you can see the fountain here. The fountain is 3 feet across and the garden is 2 feet wide around the fountain. And she plans to lay 2 inches of mulch on her garden. So how many bags of mulch should she buy? It's a lot better to know ahead of time how much mulch you need to buy rather than buying too little and then having to go to the store in the middle of the project, or buying too much and then having all this mulch left over that you don't really know what to do with. So let's help Amanda figure out how much she needs first. So we have our 2 feet across fountain, our 3 feet across fountain with a 2 foot garden around the base of it. So first, I'm a very visual person. So when I'm helping my students, I always like to make a picture. A lot of times it's more for myself than anything. So this picture is going to look similar to the picture on the worksheet. So we have our fountain. We know that is 3 feet across and then 2 feet here on the outside. That's very important. Okay. So the mulch that is going to go around here, around the base of the fountain, that's actually going to be like a volume because it has length, width, and height. So we know it's going to be 2 inches deep. So we already know that's kind of like the depth, 2 inches deep all the way around, but we don't know what the all the way around is yet. So let's take a look. We have this big circle. So to find the area of the circle, the area of a circle is pi r squared, where r is the radius. Now notice we have 2 circles here. We don't want the garden over the whole circle because we have this fountain in the middle that we aren't going to be laying any mulch. So we're just laying it on the outside of the circle. So we need to find the area of the big circle and subtract the area of the small circle. So first, all we need to find is the radius to plug into our formula. So for the big circle, if the small circle is 3 feet across, and then the big circle is 2 feet on either side, the diameter is 2 plus 3 plus 2. So that would be equal to 7. The radius, that's the diameter. The radius is half of that. So 7 over 2, or 3.5. So if we plug that into our equation here, pi times 3.5 squared. And I have that calculation already ready for us. It's approximately 7.069. So approximately, because pi is an irrational number. So we're always going to have to round when we're using pi. So 7.069. That is the area. Let's go back to my picture so you can see a better picture. That is the area of this green part here. 7.069 is. So now that we know the area, all we need to do is multiply it by the 2 inches deep that she wants the mulch to go. So this is in feet. We have 2 inches deep. So we want the area times the depth of the mulch is the volume of the mulch. So I'm just going to say that's 7.069 times, we don't want to say times 2 because 2 is in inches. We would be doing feet times inches. We don't want to do that. So we need to change inches into feet. We know that there's 12 inches in every foot, or 1/12 of a foot is 1 inch. Well, we have 2/12 of a foot, which would be the same as 1/6. And if we do 7.069 times 1/6, we get approximately 5.236. So I'll just say 5.2. Now she needs bags of mulch. So she needs enough bags of mulch to cover. So it doesn't matter what the number is, if it was 4.1 or if it was 7.3, we always need to round up. We need to make sure that we have enough. So we have I think it said in the question that each bag of mulch contains 2 cubic feet. Well, we need 5.2 cubic feet. So we're going to divide by 2. We don't need to know exactly what this is, but we do need to know that it is 2.6, but we need to know how many bags of mulch. Well, we can't get 2.6 bags of mulch. The store won't sell that. So we need to round that up to 3. So she needs to go to the store and buy 3 bags of mulch. That will be enough. She'll have a little bit left over, but maybe she can just put a little bit extra on the top. But at least she'll have enough, and she won't spend too much money buying too much that she doesn't need, and she won't get too little so that she can't have enough for her garden. So that's Amanda and her garden. That is a good one because it has a circle, and circles are everywhere. In this case, it was a garden. It could be, a piece of art that you're wanting to paint and you need to know if you have enough paint or something like that. But circles are something that we use all the time. So let's take a look at another shape. And this one is a triangle. So Evan built a triangular fence as shown in the image. Angle A is 10 degrees more than angle B, and angle C is 30 degrees less than twice as big as angle B. What are the measures of the three angles? So here's a little bit of algebra translation. So if you've ever had algebra, very, very early on in the book, there's going to be a section on translation and how to translate words into math, into symbols, into numbers. So we know that angle A is 10 degrees more than angle B. So if we go over to our whiteboard here, angle A is 10 degrees more than. More than means it's additional, so we're going to add it. So A is, always stands for equals, and is the same as B, except it's 10 more than that. So we're going to add 10 to that. So that's our first equation we're going to use. But we have three angles, so we're going to need three things we need to use. The angle C is 30 less than, so just like more than was plus, less than, we're going to be subtracting 30, but it's not just 30 from C, it's 30 from B. It's going to be 30 from twice B, so 2 times B. So back to our whiteboard, C is 30 less than, so you usually are going to be subtracting from the end. 30 minus isn't going to make sense because the angle is bigger than 30. We would get a negative. You can't have negative angles. So we know that it is minus 30 at the end, and it's minus 30 from twice B. Now this is great news. We have three angles, and we have two equations that are both in terms of B. Now, we do need three equations to be able to solve for three variables. That's how systems of equations work. You need as many equations as you have variables. If you try to do anything with just these two equations, you're not going to be able to solve anything. You're still going to have a variable in one of your equations. That's where the geometry especially comes in, because we need to know something about this triangle, about the angles of the triangle. So if you think to all the things that you know about a triangle, one of the very first things you learn is that a triangle has how many degrees in it? Well, it has 180 degrees. So that means that the sum of all the three triangles add up to be 180 degrees. So we can say A plus B plus C equals 180. So now we have three equations, three variables. That's perfect. That's what we needed to solve this equation. Now, we don't really know anything about B. We had this A formula and we had this C formula. But we can substitute in what we know A is in for A and what we know C is in for C. Then we'll have just B's left, which is good. One equation, one variable, we'll be able to solve it. So plugging in for A, we have B plus 10. That's what A equals, remember from the question. Then we have plus B. Again, from the question, we didn't find anything out about B. That's okay. That's what we're going to be solving for. And then plus C. C from the equation was 2B minus 30. So 2B minus 30. And that's A plus B plus C equals 180. Now, all we need to do is some pretty basic algebra to be able to solve for B. So adding in all our like terms, we have 1B, 2B, and here's another 2B. So we have 4 B's, and then we have 10 minus 30. So minus 20 equals 180. I'm going to erase some, or I think I'll just squeeze it here at the bottom. We have enough space. So I'm going to add 20 to both sides here. So add 20 to both sides. That gives us 4B. The 20s cancel here. And then 180 plus 20 is 200. Now all we need to do, divide both sides by 4. And we get B is equal to 50. Now we're not done. We needed to find all three angles. We know B is 50. That's great. Let's go back up to our formulas. If we plug in B to our A formula, we'll be able to find A. And if we plug B into our C formula, we'll be able to find C. So plugging B in, or B is 50. So 50 plus 10 is 60. That's what A equals. And then this one's a little bit more work. 2 times 50, so that's 100, minus 30 equals 70. Now, I always tell my students on a test, the first important thing to do is answer all the questions. So if you're taking a standardized test, answer as many questions as you can. But sometimes you'll have a little bit of time left at the end of the test. A great thing to do, rather than just waste your time twiddling your thumbs, is to check your answers. A very, very easy way to check this. Remember that all 3 of the angles are supposed to add up to 180. So let's take a look. We got 60, 70, and 50. So if we did it right, those should add up to be plus 50. Those should add up to be 180, and indeed, they do add up to be 180. So if you can check your answer and figure out, oh, that answer makes sense, then you're probably right. And that's a great thing to be able to know on your test, is if you got it right. All right, so that was triangles. Triangles, another really common thing that's going to be on standardized tests. So let me clear my whiteboard a little bit for our next problem. All right, back to our worksheet. Number 3. Now, sometimes, before I even read the problem, I'm going to say sometimes you'll be given a picture. Sometimes the question will just be the picture, like what you can see here with the 18 feet and the 16 feet. Sometimes you'll just be given a picture. Sometimes you'll just be given the word problem and you need to draw the picture. I thought it would be easier if if the picture was already on the worksheet, but you could easily do this, draw a picture, if there was just a word problem. Sometimes you need to do that. And especially for someone like me, I love to be able to see it. So it's really important for me to draw myself a picture. So let's take a look at number 3. Oliver is painting the walls of his living room with dimensions given in the image. So if the picture hadn't been given, they probably would have given you the dimensions. To save time, we just put it in the picture. The ceilings are 10 feet tall, and there is 1 3-by-8 foot door and 2 2-by-4 foot windows. Now that's important information, which we'll see in just a second. If 1 gallon of paint covers 400 square feet, and he bought 7 gallons, how many coats of paint can he paint the wall? So he already bought the 7 gallons. So now we're just trying to calculate how many coats. He doesn't want to get halfway through the last gallon and run out of paint. And so like one wall has 2 coats and one wall has 3 coats. They're not going to be the same color or the same richness of the color. So he doesn't want that to happen. So he wants to know how many whole coats can he cover the walls of his living room with the paint before he gets started. So let's take a look at what kind of problem we're doing. Now, this is the floor plan, but walls are straight up and down. So the floor plan shows us what the base or the length on the bottom of the wall is, but the height of each wall is 10 feet. Now, the door and windows is significant because you don't paint the door and the windows usually, definitely not the windows. So we're actually going to subtract that out. We're going to find the area of each of the walls, but then we're going to subtract out the door and the window because he doesn't need to paint those. So I'm going to transfer this picture over to our whiteboard. And it is an oddly shaped room. So if you have just a rectangular shaped room, this is a much easier problem, but that's okay. He lives in a kind of odd shaped room, which is why we're helping him out. Okay, now not all the sides are given here. We have this big side that's missing and this little side that's missing, but we can easily figure that out. We don't know what this big side is, but we do know that these 2 smaller sides, 18 and 14, add up to this big. This is called a composite figure. It's 2 rectangles composed together to make one big shape. So we're just going to add 18 plus 14 to get 32 for our big side. And then this little side right here is 16 minus 12, because we need these 2 sides, the 12 and the small side, to add up to 16. So 16 minus 12 is 4. So now we have the dimensions, all the dimensions that we need. I'm going to split this up into 2 rectangles. There's multiple different ways that you could do this. The way that I showed in the answers on the worksheets is one way. You could also find each room separately. There's other ways that you could do it that you might have already thought of doing it. I'm going to show you one way. I just want you to know that this is not the only way that you could do the problem. So the area of each wall is base times height. It's a rectangle, so base times height. And I would say a vast majority of the time, unless you're in some kind of artistic building, a wall is the shape of a rectangle. So base times height. So we know the height is 10. We know that from the question. The height of each of the walls is 10 because that's how high the ceiling is. We just don't know the base. Well, the base is the sum of all of these sides or the perimeter of the room. So we're going to take 10 and we're going to multiply it by the sum of all of those sides. So 16 plus 18 plus 4 plus 14 plus 12 plus 32. That's going to be what our area is. That's going to tell us how much paint he needs, and then also minus, remember, we need to subtract the doors and the windows. So I already have the answer ready for us here. It is 960 square feet. So the area of all the walls is 960 minus, now let's look back at the problem for this one. We have here the area of the doors and the area of the windows. You can see they're in the middle. So the door is 3 times 8, which is 24. There were 2 windows and they were 2 by 4. So 2 times 4 is 16. So 24 and 16 is the area that we're not going to be painting. So minus 24 plus 16, which is 40. So 960 minus 40 is 920. Now we're almost done. 920 square feet is how much wall he's going to need to paint. That's from our last problem. Let's see if we can get rid of this. Maybe. So all we need to figure out then is if he has 7 gallons, how much can he paint? So it said that each gallon of paint covers 400 square feet. So if he has 7 gallons times 400 square feet, that means he has 2,800 square feet of paint that he could use. He needs it for 920 square feet. So dividing by 920, oh, that's 920, not 9.2. That is approximately 3.04. Now, remember how last time we rounded up to make sure that she had enough mulch? This time we don't want to round up. We need full coats of paint, 3.04 coats of paint. We can't round that up. He would need to get more paint. So we're going to actually round this down to 3. He doesn't want to get started on his 4th coat, get 0.04 of the way around, and then have to stop. So we're going to round down. He can do 3 full coats. Then he can know that before he even gets started that he's enough to do 3 full coats. Okay, last problem. I hope this is being helpful for you. I know sometimes you get onto the test and then you get up to a problem like this and you just don't even know where to start. The biggest thing is knowing which formula to use. If you can know which formula to use, a lot of times that is going to help you out a lot with just plugging the numbers into the formula. And a big part of that is knowing what shape it is. So if there's a drawing, great. If there's not a drawing, make one. Okay, our 4th problem here is about Matthew. Now this one is kind of like trigonometry. We're not actually going to use trigonometry for this one, but you would see a problem like this in a trigonometry course also. We're not going to use trigonometry because we don't have any angles. Here we just have heights. So we're actually going to we don't see a shape here. This one's a little bit different because it's a real life. The shape is actually imaginary. So let's take a look at number 4. Matthew is admiring an eagle that is perched at the top of a tall tree. Matthew's line of sight, where his eyes are, is 6 feet off the ground, and he is 8 feet away from the tree. He knows that the tree is 12 feet tall. What is the distance between Matthew and the eagle? Now, he can't just take a tape measure and measure the distance. First of all, it's up in the air, so the tape measure probably won't even go. Second of all, he might start putting the tape measure up and the bird will fly away. So he can do a calculation to figure out if, for whatever reason, he wants to know how far away from the bird that he is. So I'm going to transfer this information over here. We know that the tree is 12 feet tall. He's 8 feet away. I'm going to put the feet here. 8 feet away. And where he starts looking is 6 feet off the ground. That's important because we don't want to make this is going to be like the hypotenuse of our triangle you see in a minute. We don't want to put that to the ground because his eyes are not on the ground. His feet are on the ground. His eyes are kind of like up in the air. So this is going to make a triangle after we add an imaginary line here. So see how now we have a triangle? We are looking for this distance, the distance from his eyes to the bird. We're going to use the Pythagorean theorem. We have two sides. Now, it might not look like we have two sides of this triangle, but we do, because this imaginary line right here is the same as his distance away from the base of the tree. So that's 8 feet. Now, the tree is 12 feet tall. So this whole big long side is 12. That's not the short side. That's this long side right here. But we, just like in our composite figures in the last problem, we're going to subtract. We know this little piece, we know the big piece, we need to find this little piece by doing 12 minus 6. So that's 6 here up at the top. And whenever we know two sides of a right triangle, we know this is a right triangle because the tree is perpendicular to the ground, at least if it's a healthy tree. So we're going to do Pythagorean theorem. A squared plus b squared equals c squared. Another way to write that is c, the hypotenuse, is the square root of a squared plus b squared. So putting in our a and b, it doesn't matter which one's a and which one's b, 6 and 8, it doesn't matter which order because we're just going to be adding them. And addition is commutative, meaning we can do it both ways. So if you put the 8 in for a, it would get the same answer. But I'm going to put 6 in for a. So this is equal to the square root of 6 squared, or 36, plus 8 squared, or 64. Add those together, we get the square root of 100, which is very nice. It worked out evenly. The bird is exactly 10 feet away from his eyes. So that's just 4 problems, very similar to what you might see on a standardized test. I try to do all different kinds of problems using different types of shapes. Sometimes you need to find the area, sometimes you need to find the length, sometimes you need to find the volume. But I think these are all kinds of problems that you might actually see in real life someday. So it's very important to be able to know how to solve them. And also, especially you as a student, to know how to answer it and get the correct question on the test. I think Tiffany was going to say something here at the end. If not, I can close this out. There she is.
Thank you so much. This was extremely fun and helpful. And I know that this is like just a mini version of what we do in tutoring sessions, right? This is just a taste of what some of our tutoring sessions are like. But this was so helpful. And the different types of problems that students will encounter in school, but also in life, right? So I think sometimes making the connection for students is really what gets them to understand, like, why are we even learning about the Pythagorean theorem? Where is this going to come up in my life? And these problems are, perfect examples of where you're going to actually see algebra and geometry in real life. So thank you so much, Rebecca, for providing this math mini workshop for us. And for everyone who's listening or who tuned in today live, thank you for joining us. And we are going to be having a series of math mini workshops throughout the rest of the winter and spring and throughout the summer as well. So please stay tuned, and we'll be delving into some more math topics maybe even some science reading topics. So yeah, we'll keep you posted, and keep us in mind when you are working with your students on these types of problems. Thanks, everyone, and have a wonderful rest of your Saturday.